So this is December 2018. December 2018. The impeller of centrifugal pump has the following specification. So given uh, design flow rate Q. So design flow rate Q is 0.2 meter cube per second, and then design speed, blade speed is 2000 RPM revolution per minute, and then diameter for impeller D2 is 0.3 meter ataupun R2 equal to 0.15 meter, and then blade impeller outlet width beta 2 equal to 0.03 meter. Blade angle beta 2 is 20 degree. So this is all the given specification for this centrifugal pump. And then assuming the inlet flow to the pump is radial. So this is very important information. Okay, so inlet flow to the pump is radial. Okay, and then A solution. Sketch the velocity diagram at the inlet and outlet of the pump. Okay, so I think for the velocity diagram you can refer to notes how to draw the velocity diagram at the inlet and outlet for the pump. Okay, so let's say this is your centrifugal pump. Okay, so this is to make it easy. So this is radial, and then this is tangential. Okay, so this is 1 and then 2. Okay, so this is point 1 for the inlet, point 2 for the outlet. Okay, so for the inlet, the given parameter, the given flow rate, given inlet flow is radial, mean that at point 1, which is inlet, the the velocity, okay, the absolute velocity enter the pump radially. Okay, so this is V1, and then we have, let's say, this is our omega, okay, omega, and then we have V1 absolute velocity. This is U, okay, U, which is blade speed, and then so this is W, which is relative velocity at the inlet. Okay, so V1 equal to W1 relative velocity at 1 plus blade speed at 1. Okay, so kita akan dapat V1. Since the pump the flow enter the pump radially, so at this stage V theta 1 equal to 0. Okay, so V1, this is V1, and then we are no V tangential for this case. Okay, so there was for inlet. For the outlet, okay, so for the outlet, we can draw it here first. Ada yang nak masuk ke? Saya tak nampak ni. Sekejap.
Macam ada.
Okay, so for the outlet, beta 2 is given 20 degree. So we can draw the beta 2 first. So, sekejap. Sepadam ni. Okay, so angle, which is angle between this, okay, so this is angle, which is beta 2, and then this is angle between relative velocity. Okay, angle between relative velocity, which is W2. Okay, and then this is relative velocity W. We can draw U2, which is blade speed at 2. So blade speed always tangential to the casing ataupun to this point 2. Okay, so this is U. Tak straight tangan saya. U2. Okay, and then we know that from definition, V2 equal to absolute velocity is the summation of relative velocity plus dengan U, which is blade speed. Okay, so sekejap mana masuk lagi. Okay, so W1, sorry, V2 equal to W2 plus with U2. Okay, so susah macam ni, kita buat ke sini W2 tambah U2 equal to V2. Okay, so this is how the velocity triangle at point 2, which is outlet. So we can redraw at this here. So you have we have W2 with beta 2, and then we have tu sangat saya punya tangan ni. So this is U2, and then U2, this is V2. Okay, so setuju? Ada yang dapat lain? Any question for solution A? So V2 equal to absolute velocity at the outlet equal to relative velocity W2 plus with U2, which is blade speed. Okay, and then the V2, for the V2, we have component of radial, which is here, R2, and then V, dia sini ke sini, V theta 2. Okay, so this is velocity triangle at inlet and outlet for this case. Ada soalan lagi? Ada soalan? Boleh proceed to B?
Boleh.
Boleh. So B, calculate one theoretical head input by the impeller. Theoretical ataupun ideal. theoretical or ideal for the head input by the impeller. So kita kalau dalam notes HI ataupun HP, so kita ada H ideal ataupun H theoretical. So how to find the theoretical head for this centrifugal pump? Ada siapa yang dah buat? Macam mana cari theoretical ataupun ideal? Ada buku, setengah buku guna ideal head, setengah buku guna theoretical. Ada siapa dah buat?
Pakai equation je.
Question mana?
Yang U2 squared over G tolak U2 cotangent beta. Semua tu rasa.
Okay, so kita ada dua, betul tu. One, kita ada two methods, bukan two method, two equation to determine H theoretical. Okay, one is HI equal to mana siapa cakap ni? U2 square over G minus with U2 VR2 cot beta 2 cot beta 2 divided by G. Okay, ataupun satu lagi H I equal to sama sebenarnya 1 over G U2 V theta 2 minus U1 V theta 1. Okay, so you akan dapat equation sama. HI guna this equation ataupun HI guna this equation. In fact, kalau you nak guna this equation, V theta 2 is determined based on cot. Okay, so sama je. So sekarang ni, let's say we want to use this equation HI equal to U2 square over G minus U2 VR 2 cot beta 2 over G. Okay, so now U can be determined based on the blade speed. Okay, we can determine U, and then VR2 can be determined based on design flow rate, and then beta 2 is given. Okay, so kita cari satu. How to find U?
U equals to omega R.
U equal to omega R, betul? So omega equal to 2 pi n. 2 pi n apa? N 2000. 2 pi kali 2000 kali dengan 1 over 60 sebab kita nak dalam second, betul?
Betul.
Kali R2 apa ni? So dapat apa?
31.4159.
4142 So semua dapat U equal to 31.42 meter per second. Okay, so we got U2, and then we need to find VR2, betul?
Betul.
VR2. So how to find VR2? Based on flow rate. So flow rate Q equal to
2 pi R2 B2.
pi R2 B2 darab dengan velocity, radial velocity VR2. Okay, so 2 pi R2 0.15 B2 is given 0.03. BR2, BR, kena cari BR2 Sorry.
Flow rate dia bagi.
Got it. BR, VR2 equal to Q over 2 pi R2 P2. Q is 0.2, 2 pi, R2 is 0.15, B2 is 0.03. So, berapa dapat VR2?
Tujuh.
7.0. Nilai pun dapat sama. Okay, so now H theoretical ataupun H I equal to U2 square. U2, mana U2? Okay, tu 61.42 square over U2 VR2 beta 2 is okay, so dapat apa? Apa?
38.38.
So this is the answer to 38.38 meter. Semua dapat sama? Semua sama dapat?
Fix dapat 38.41.
Okay, lebih kurang sama. Okay, so ada soalan setakat ni? Any question? Ada soalan? No question?
Tak ada, sir.
Okay. So B2. Calculate the actual, makin kecil saya punya ni. Calculate, nampak? Calculate the actual head developed by the pump if the internal losses are 50% of the pump exit kinetic energy. Okay, so now the question asks you to find the actual head if the losses, the only consider losses is 50% of the pump exit kinetic energy. Okay, so now dia nak cari H apa? H actual ataupun H pump. So any idea how to solve for this?
Tak ada idea, sir.
Ada
Tak ada.
kinetic energy? Okay, so for the head actual ataupun head pump, so tengok balik you punya nota for the actual. Okay, so H actual ataupun head pump defined as P2 minus P1 over losses head due to the pressure P2 minus P1 lambda plus Z2 minus Z1 due to the elevation difference, and then V2 squared minus V1 squared over 2G. Okay, so this is head due to the kinetic energy. Okay, so now question B2, only consider internal losses 50% of the pump exit kinetic energy. Okay, so V2 over 2G ni apa? Rumus untuk apa? V2 squared over 2G. Rumus untuk?
Bernoulli je.
Tak ni, V2 squared over 2G. Question ni apa?
Kinetic energy.
Kinetic energy. So basically this is kinetic energy. Okay, so now we need to find V2. Okay, we need to find V2. Kita tak jaga lagi V2. Kita ada U, ada VR. Okay, so kita kena cari V2. Okay, and then dah dapat V2. Once you obtain the V2, you need to divide by 2 sebab 50%. Okay, so now how to get V2? So yang ni dia tak consider. For this case, dia tak consider only exit. Okay, only exit kinetic energy, which is V2. So macam mana, how to find V2? Any idea how to find V2?
Bina velocity triangle.
Yes, velocity triangle. So based on this velocity triangle, ni V2, this is V2. You dah ada U2, betul? Mana U2? Tak ada lagi, ni. You dah ada U2, and then now you only need to find V2. Okay, based on velocity triangle. Ataupun sama V2 based on this triangle, you can find V2 also equal to relative velocity 2 W2 tambah dengan tambah U2. Okay, so blade speed at point 2 is already determined. Now you need to find W2. Where is W2? This is W2. So how to find W2? Okay, so this is beta. Here also beta, betul? Ke sini beta, ke sini pun beta, betul? Betul? Ke saya salah?
Betul.
Okay, so W2 equal to apa ni? Cos. Let's say kita guna cos ataupun guna sin. Sin beta saya tentang boleh guna sin. Sin sin beta, okay, ni sin biru ni. Sin beta equal to tentang V R2 hypotenuse W W2. VR2 kita dah ada ni kan sebab kita dah cari 7.07. So kita akan dapat W2 equal to VR2 sin divided by sin beta. So VR2 7.07 bagi dengan sin beta sin 20. So you akan dapat W2. Berapa?
7.744.
7.7.
44.
Yang lain dapat sama? Okay, so since W2 is 7.744, so we can find V, okay, which is W2 7.744 plus U2, which is 3142 meter per second. So sini dapat apa?
Sir, jawapan nak dalam degree ke radian
Yang mana?
untuk W2?
W2 ni degree. W2 velocity, bukan angle.
Tak, sebab kalau calculator guna radian, dia akan dapat 7.744.
Apa? Angle degree lah. Sin 20 degree.
Dapat 20.67 untuk W2.
Yang ni? Oh, yang ni sama. Yang ni
Oh,
juga.
tadi saya guna radian.
Oh,
Silap.
ni. Yang ni betul kan? Betul kan? Ni tak guna radian kan? Untuk kod.
Kod tak.
Okay. Jom. Mana pemadam? Jangan salah dalam exam radian dengan
Oh, saya guna radian. Patut ada tadi tak dapat sir.
dua puluh apa?
20.67.
20.67.
Betul.
Ni berapa?
52.09.
So this is V2, 52.09 meter per second. Okay, so now ni to find the so to find HA V2, which is 52.09 square bahagi dengan 2G kali dengan apa nama ni 50% 0.5. So you akan dapat berapa? Apa?
69.148.
Sama je. 69.15.
15.
69.15.
Mana? 69.15 liter. Okay. So ada soalan setakat ni? Any question?
So yang 0.5 tu yang mana sir?
Itu 50%.
Oh, 50%. Okay.
Okay, ada soalan? Yang lain? Okay, so tak ada soalan, kita proceed. C itu last. A water supply system requires a head of 60 meter and flow rate of 0.15 meter per second. Okay, state the arrangement to be used to meet the supply system requirements if two identical centrifugal pumps from question 4B are to be used in the system. Just state the arrangement. Okay, justify your answer. Okay, so for this question 4C, 4C betul. You don't have to calculate, but you just need to justify. Okay, so anyone? Ada siapa ada apa jawapannya ni? Ada yang dapat? So pump arrangement ada berapa?
2.
Dua, satu series, satu
Parallel.
parallel. Kalau series apa yang berubah?
H.
H ni. Macam ni saya nampak ni. Jap. Okay, so C. Saya buat sini. C. Pump arrangement ada dua. Series parallel. Okay, so what happened when you install pump in series?
H total equals to H1 plus H2.
H total equal to H1 tambah dengan H2. So what happened when you install pump in parallel? Apa yang tambah?
H dua-dua sama.
H sama. Yang tambah apa?
Q.
Q So Q total equal to Q1 plus Q2. Okay, so this is principle of pump arrangement. If it is in series, okay, so if it is in series, the total head will be double, which is H1 plus H2. And then for pump installed in parallel, the head might be similar, but the total flow rate will be double. So Q1 sini, and then Q1 sini, Q1 plus Q2. Okay, so referring this question, yang dia nak berapa? The water system required is 60 meter. Okay, requirement head equal to 60 meter. Q requirement is required Q is 0.15 meter cube per second. Okay, so apa yang paling ideal for this case based on your calculate 4B and then based on the design specification? Nak guna series ke nak guna parallel?
Pakai series je.
Series sebab apa?
Head dia
Sebab
60 meter.
Sebab kita nak head at least 60 meter. Okay, if let's say we for this case H mana H ideal ni? Okay, so H ideal 38.38 meter. Okay, 38.38 meter. But now the requirement requires 60 meter. Okay, so kalau kita guna satu pump tak cukup, we need to add another pump. Okay, so we need to add another pump in the sense that the arrangement must be in series. Okay, sebab apa in series? Because we want to double the total head. Okay, instead of 38.38, now we can get more than 60, which is 76 meter. Okay, so the answer is we need to install these two pump in series so that the total head will be double from the design requirement, and then the Q, the flow rate, okay, flow rate, the required flow rate Q required is 0.15 meter cube per second. Okay, so our design flow rate is 0.2 meter cube per second. So still in the range of our design flow rate. Maknanya kita just guna this two pump and install in series. Okay. Kenapa tak boleh install in parallel? Sebab if you install in parallel, okay, if you install in parallel, you will get over over design. Okay, so you can get Q total Q1, which is 0.2 plus 0.2 equal to 0.4 meter cube per second. Okay, whereas you just only need 0.15 meter cube per second. Okay, so by install in these two pump in parallel, the total head will be only equal to the 38.38 meter. Tak sampai pun requirement kita 60 meter. Okay, so ada soalan?
Tak ada sah.